So we are going to start today on, we have actually combined units 1 and 2. So if you notice on the board it says unit 1/2 or comma 2. Okay, so we are actually doing 2 units in 1, and we are on our first objective today. So unit 1 and 2.1, and we are going to be solving absolute value equations. Solving absolute value equations. Let me zoom that in just a little bit more. So, it is not up just yet, but I will be putting together something called a word wall, okay? Just some vocabulary that we use a lot that I want to make sure that you're using correctly. So, within your group, and I will randomly pick someone at the end of this, within your group, I would like you to tell me, what does it mean to solve something? Okay, what's the difference basically between solving and simplifying? So, talk amongst your group, try to come up with an answer, and then I'll randomly pick someone, and you're going to tell me what your group thinks it is. So, difference between solving and simplifying. What is the difference between solving and simplifying? And yes, there is a difference. Difference between solve and simplify. So, do I have any volunteers to tell me what does it mean to solve something? Anyone volunteer? I'm going to get a name. Austin. Okay, listen, because I might ask you to explain this. Austin. Get an answer. Okay? What's the difference between solving and simplifying? Did you come up with that?
Yeah, solving is getting an answer, simplifying is breaking it down as much as possible.
Okay, solving is getting an answer. Simplifying is breaking it down as much as you possibly can. Anyone have an alternative thought? Thomas?
Solving is finding a solution, and simplifying is a way to get to a solution.
Okay, solving is finding a solution. Simplifying is a way to get to a solution. You are both pretty much correct, okay? The only difference between if something says to solve versus simplify is a solving equation basically means to get an answer. Okay, so that just tells you you're going to get an answer when you have something equal to a variable. And the difference here between solve and simplify is basically how the equation is written, or excuse me, how the problem is written. If it has an equal sign, you're going to be solving. So that just means get an answer equal to a variable. Does anyone know what a variable is?
Like a letter representing something else.
Right. A variable is a letter in math. So when a letter represents a number. So solving versus simplifying. Now, along those same lines, very, very similar to that, does anyone know what is the difference? So within your groups, I want you guys to tell me what's the difference between an equation and an expression. Okay, difference between equation versus expression. Think it's very similar to solve and simplify, the difference between the two of them. So within your group, try to figure out what is the difference between an equation and an expression. Equation versus expression. Not hearing much talking here. Okay, any volunteers to tell me what's the difference between equation and expression? Okay, Sonali, what does your group think? Only because I know your name. Exactly, an equation has an equal sign in it, okay? So an equation has an equal sign in the original problem. Okay, so an equation has an equal sign in the original problem. An expression does not. Okay, the steps that you do in both of them are virtually the same. But an equation means it has an equal sign in the original problem. An expression does not. Now, the big one here that I want to teach you about today is an absolute value. Okay, so absolute value. Anyone think they know what is the definition, or what does absolute value mean? Anyone think they know? Thomas?
An absolute value cannot be negative.
Okay, that is a rule about absolute values. They cannot be negative. But what is an absolute value?
Is
Kelly?
it like not going to change?
Not going to change, okay. Good ideas? Not quite right, but good ideas. Anyone know? The absolute value is actually the distance from 0. Okay, so an absolute value is the distance from 0. Now, Thomas was correct in that it is always positive. Okay, and actually when we're talking about distance from 0, we are referring to the distance from 0 on a number line. So, think of this kind of like driving. How many of you either have your permit or have your license? Raise your hands. So a lot of you, right? Okay. Can you ever drive a negative amount?
You can go backwards.
You could go backwards, but are you driving a negative amount?
No.
No. Okay, so if you drive from here to your house, you might drive 5 miles. If you drive from your house to here, it's still 5 miles, okay? You're never going to get a negative amount. That's why, your odometer is always going up. It never goes back down, okay? So think of absolute value kind of like the same way. So if you're moving from 0 to positive 5, you've moved over 1, 2, 3, 4, 5 spaces. Same thing if you're going to a negative. So if you move from 0 to negative 5, you're still moving 1, 2, 3, 4, 5 spaces. You're never moving a negative. So absolute value is the distance from 0 on a number line. It is always going to be positive. So we're going to start with a little rule here. And the rule is that when you are solving absolute value equations, absolute value equations, you are actually solving two separate equations. So when you are solving absolute value equations, you are actually solving two separate equations. So what that means is anytime you have an absolute value equation, whatever you have inside the bars, I'm just going to call the stuff. Okay, the stuff inside. If you have it equal to, we're just going to say a number. This is highly mathematically correct, obviously. The stuff inside equals a number. What you have to do is you're going to make two separate equations. So that becomes whatever the stuff inside was equal to the number. So basically the first equation that you're going to make is just dropping the bars and rewriting exactly whatever was inside the bars equal to exactly whatever the number was. The second equation changes just barely to be the stuff inside equal to the negative number. Can anyone look at this and tell me what's different between the first equation and the second equation? What's the difference between them? The negative. The negative is where, though? Attached to the number. Does the stuff inside ever change? No. Okay, so make yourself a note. The stuff inside, just call it stuff. The stuff inside does not change. So you are never going to change what's inside those bars. Okay, it never becomes negative like that. Okay, you're never changing it. Stuff inside does not ever change. So for example number 1, if I give you the equation and I would like you to solve, so remember a solve equation is always going to have an equals to. If I ask you to solve absolute value of x equal to 7. Solve the absolute value of x equal to 7. Solve absolute value of x equals 7. Now remember, when you break up the absolute value bars, you drop them. So when you break up into two equations, you're going to drop the bars. The first equation is just going to be whatever was inside equal to the positive number. So that one should always be fairly easy. So just x equals 7. Second equation is always whatever was inside equal to the negative number. Anything else we have to do there to isolate the x? No, so you're done. That's it. X equals 7, x equals negative 7. It is possible that you could see on a multiple choice test, you could see this written as x equals plus or minus 7, but it is not absolutely necessary that you write your answers that way. Anyone have a question on how I did that? Fairly easy. Okay, let's try another one. Number 2, I again would like you to solve the equation absolute value of x plus 3 equals 8. Absolute value x plus 3 equals 8. So absolute value x plus 3 equals 8. So first step, what is going to be my first step, Spencer? What's my first step? Drop the bars, break it into how many equations? 2. So x plus 3 equals 8. That's always your first equation. What's the second equation going to be? X plus 3 equals what? Rush? Negative 8. Perfect. Now, how do I get x by itself? For this equation, what do I have to do first to get x by itself? Subtract the 3. It's called doing the inverse operation. So, however, whatever's attached to the x, you have to undo it. So to undo addition, we use subtraction. So subtract 3. Undo addition, we use subtraction. So x equals 8 minus 3 is 5. This side, you're going to do the exact same thing. Perform the inverse operation, so subtract 3 from both sides. What do we get for an answer there? Hold on, wait for it. MK.
Negative 5?
Ooh, close.
Wait.
Oh. Ben,
Which one?
that one. Huh? Okay, let's try again. Tanner, Nelson.
Negative 11.
Negative 11. Okay, how many of you think it's negative 5? Well, obviously some of you think it's negative 5 since MK told me it was negative 5, didn't you? Yeah. MK said negative 5. Anyone else agree with MK? Who agrees with Tanner? Okay, what about the rest of you? You don't agree at all? You're just, did you get something different? Okay, I have a song to help out MK. Okay? Because I'm sorry, but you were incorrect. Tanner was right. Yay, Tanner! So, there is a song to help you with your positive and negative integers. If you would like to sing along and you know it, it's to the tune of Row, Row, Row Your Boat, and you are more than welcome. Sonali, that means you, because I know you could sing the song with me. Okay? And please do not be intimidated by the awesomeness of my vocals. Okay? Because they're bad. But it's okay. Okay, to the tune of Row, Row Your Boat. Same. It's same signs, add and keep, different signs, subtract. Take the sign of the larger one, then you'll be exact. Clap, clap. Okay, you can sing it with me this time if you want to. Sonali, come on. Humor me here, okay? Same signs, add and keep. So same signs, add them, keep the sign. Different signs, subtract. Different signs, subtract. Take the sign of the larger one. Larger one is 8, which is positive. Take the sign of the larger one, then you'll be exact. Clap, clap. If you need to sing the song to help you, you're more than welcome. Okay? You're welcome for that awesome vocals that I just gave you. So yes, we take the sign of the same signs, add and keep. So add them together, keep the sign, which is negative. Let's try another one. Number 3, example 3. Example number 3, if I give you, let's see, absolute value of x over 3 plus 1 is equal to 4. Absolute value x over 3 plus 1. Yes, that is a fraction. Yes, you will have to deal with fractions. Absolute value x over 3 plus 1 equals 4. Try it on your own. See if you can match the person sitting next to you or across from you. And I will go through it with you momentarily. So, what is the first step you should take? Angel, what's the first step you should take?
Drop the bars.
Drop the bars and make it into how many equations?
2.
2. So, x over 3 plus 1 equals 4, and x over 3 plus 1 equals negative 4. Notice, you do not change anything about the stuff that was inside. So, it was positive inside, stays positive, and you drop the bars. What would be the first step you take to solving this? Keyshawn. What would be the first step you take is solving this?
Subtract 1 from 4.
Right, so subtract 1 from both sides. Now, do I absolutely have to see this step written? No. Okay, if you can do the subtracting 1 all on your own in your head, that's totally fine. Okay, then how is the x attached to the 3? Sam. Sam next to Keyshawn. It's being divided, so how do you undo division? Multiply, so multiply both sides by 3. And Sam, help me out. What's your last initial? M. Okay. I gotta put in some initials here. Okay, so multiply both sides, x equals 9. That is your first one. So yes, your first answer should be 9. Do the exact same steps here, so subtract 1 from both sides. Same sign, so add them, keep the sign. Negative 4, negative 1 gives you negative 5. Again, to get rid of the 3, it's attached by division right now, so multiply both sides to undo it. Negative 5 times 3 gives you negative 15. Did anyone get a different answer? Because, by the way, I will totally mess up every once in a while, and if you don't tell me, everyone's going to just end up with the wrong answer. Thomas.
I got 11 and negative 13.
And how did you do that?
I multiplied first, then I subtracted the 1.
Can't do that. Okay, according to order of operations, we have to go backwards order of operations. So you always have to move this backwards.
Oh, okay.
Okay, it's okay.
Backwards?
I'm sorry, no, follow order of operations. I apologize. Yes, according to order of operations, we would do parentheses, exponents,
Division.
multiplication, division, addition, subtraction. So since we're undoing things, since we're solving for something, you actually have to go backwards. So you have to get rid of the addition or subtraction first, then undo the multiplication or addition. Okay, because we're solving for something, not simplifying. Order of operations is when you are simplifying something. So it's when there's no equals, and you're all doing just one side of an equation. Okay, let's try another one. Let's try. Okay, number 4. Number 4, I would like you to, again, solve all of these equations we're going to ask you to solve today. Solve absolute value of 5x minus 3 is equal to negative 17. Solve absolute value 5x minus 3 equals negative 17. Absolute value 5x minus 3 equals negative 17. Anyone think they have an answer for me? Anyone think they have an answer? Ben, what did you get? Say it again. X equals 4. Did you only get one answer? Or did you get 2? Oh, that's your first answer. Okay. Anyone else get another answer? So I've got an x equals 4.
I got x equals 100 for record.
100. Okay. So I've got a 4 and 100. Did anyone get a different answer? So you're all agreeing with 4 and 100. Tanner?
14 over 5.
14 over 5. Okay. So anyone else get 14 over 5?
I got negative 14.
And we got a negative 14 over 5. Okay, this is a problem. Did anyone get anything else? Sonali. You got 3. You guys are scaring me right now. Great. Look back at, well, at least it was my first one here.
So is it?
What does this say?
Oh, always
The absolute value of something is always positive. I tricked you. Basically every single one of you. Can the absolute value equal a negative answer? No. This is no solution. You can't do this problem. Okay? No solution. Okay? No solution. This will happen on your homework. This will happen on your quizzes. This will happen on your test. Now, this is different than if you drop the bars. Okay? When you drop the bars, it can equal a negative because it's not the absolute value anymore. But once you drop the bar, or once it's in the bars, when it starts in the bars, it cannot equal a negative answer. So be careful on that one because I tricked a lot of you. Okay? Please, please, please be careful on that one. Okay, let's try another one. Number 5. Okay, absolute value, we are solving for number 5. Absolute value of x minus 7 equals 2. Absolute value of x minus 7 equals 2. Absolute value of x minus 7 equals 2. This is a little bit tricky because it looks different. Okay, anyone think they have an idea of what we have to do first? Isaac.
No, I just did it.
Oh, you have an answer?
Yeah, but
How can you have an answer if you can't tell me what we do first?
Yeah, it's complicated.
It's complicated?
Yeah. Can you say that?
Let me make your life easier. Show your work and it'll make me happy, please. Okay, what did you get for answers then?
9.
Anything else? Answers, plural. Look at just one. That's not quite. Can we give you a heads up? It's either going to be no solution or 2 different answers. So you're halfway there. You've got one answer. Can anyone now, back to my original equation, can anyone tell me what's the first thing I should do, Jalen? First thing, I get drop the bars. Does anyone disagree? Ben. You say add the 7 first, okay? I'm sorry, Jalen. Ben is right, okay? Make yourself a note here. This will be helpful to you, okay? Absolute value bars, so you just put the bars, must be by themselves. Or must be by itself. Before, and yes, I just wrote before you make 2 equations. So what that basically means is before you can make 2 equations and drop the bars, the only thing on that side of the equation can be the absolute value bars. So you have to get the absolute value bars all by themselves on that side before you can make 2 equations. So Ben was right. First thing you want to do here is actually move the 7. So we're going to add the 7. Again, you're using the inverse operation. So add the 7. Then that'll give you absolute value of x equals 9. Notice, I did not say x equals 9 because I have not dropped to the bars yet. Okay? Now, Isaac, now you drop the bars. So drop the bars, whatever's inside equals the positive, whatever's inside equals the negative. Then, if you needed to, if there was anything else still left attached to x, you would solve. Here, you're done. We have 2 answers. We're happy. Anyone have a question on how I did that?
Do our notes only have examples today?
As opposed to what?
Are we going to write like actual notes, like words? Or are we just
Oh, no, these are notes, yeah. Oh, by notes, yeah. By notes, I mean examples, yeah. There's like a word in there, solve, maybe. That makes you happy. Okay, let's try another one. I'm going to try 2 more with you. Okay, number 6, 2 more and then we'll be done. Again, I want you to solve negative 2, absolute value x minus 3 equals negative 10. Negative 2, yeah. Uh-huh. Negative 2, absolute value x minus 3 equals negative 10. Think about this carefully. Anyone think they can look at this equation and give me the answer that fast? Keyshawn. Okay, anyone else think this is no solution? So about half of you believe Keyshawn. Okay? I'm sorry, but you're wrong. The reason that you are wrong, though, is because does this say the absolute value equals a negative number?
No, because negative 10 divided by
No, it says negative 2 multiplied by the absolute value equals a negative number. So we actually cannot make that determination until you have the bars by themselves. So, very nice try. I'm sorry that I messed you up. So, what is the negative 2 attached by? Is it attached to the bars by add, subtract, multiply, or divide?
multiplication.
By multiplication. So there's technically a little multiplication dot here. How do you undo multiplication? Division. So divide everything by negative 2, both sides. Divide everything by negative 2. You still have the bars. Remember, I do not drop these bars until I'm ready. So you're making 2 equations, you don't drop the bars. Negative divided by negative gives you a positive. So is this no solution?
No.
No, you can get 2 answers. So break this apart into 2 equations. X minus 3 equals the positive 5, and x minus 3 equals the negative 5. Notice, this negative does not turn positive. You write exactly what was inside the bars. That stuff does not change. Then, using the inverse operation, I want you to solve. So, to get rid of the negative 3, what do I do, Monique?
You add.
Add 3. Right. So add 3, to both sides. X equals 5 plus 3 is 8. Same thing on this side. Add 3 to both sides. These are different signs, so subtract them. 5 minus 3 gives you 2. Keep the sign of the larger one, which is negative. So 2 different answers here. X equals 8 and negative 2. Okay, I have one more example, and then I promise I will be done talking. Or with notes. Okay, again, I would like you to solve. This is something that I would call very test missable, meaning there's one just like this on your test, and a lot of people miss it. Okay, so 3 plus 2, absolute value x plus 6, close your bars, equals 9. 3 plus 2, absolute value x plus 6 equals 9. Anyone have a guess or any idea at what is the first step here? Daisy, were you going to raise your hand? Okay, make a guess. What do you think is the first step here? Add 3 and 2. Okay, anyone have a different guess? Anyone think we should do something different besides add 3 and 2? You're all good with that. Everybody thinks we should add 3 and 2. Say it again. I heard someone. There was someone over there. Tyler, Sam, one of you. Tyler.
I thought we should I don't know what it is,
Distribute the 2? No, sorry. That's with parentheses, not absolute value bars. Okay, first thing you have to do here is, how is the 3 attached to the absolute value bars? By add, subtract, multiply, or divide. The 3 is attached by addition. How is the 2 attached? By multiplication. Are those like in the same absolute, or are those in the same order with order of operations? Do you do those? Are they the same level? No. Okay. You have to undo the 3 actually first. This is when we're doing the reverse order of operations to do inverse operations. So start by subtracting 3 from both sides. Okay, start by subtracting 3. That'll leave you with 2 multiplied absolute value of x plus 6 equals 6. Now, we just got through saying that 2 is attached here by multiplication. So to undo multiplication, what's the inverse operation? Divide. So divide both sides by 2. That leaves you with absolute value x plus 6 equals 3. Now, once you have the bars all by themselves, you break them apart to become 2 different equations. So x plus 6 equals 3. The first one's always really easy. We just rewrite but drop the bars. The second one, rewrite what was inside, change the sign to be negative. Using the inverse operation, how do I get rid of the 6? Do I add, subtract, multiply, or divide? Subtract. 3 minus 6 gives you a negative 3. On the other side, subtract 6 again. same sign, so add them together. Keep the sign, which is -9. Any questions so far? Okay, I'm gonna give you guys your packets. You are doing numbers 1 through 22 for work tonight. Okay?